When I'm asked to factor a trinomial that looks like this, okay, notice this is a trinomial. It has three terms. Oof. It has three terms. Okay, so that's one thing to observe. The other thing to observe is that this x squared is by itself. Okay, it's not 3x squared, it's not negative 2x squared, right? It's not these things. It's just x squared by itself. And so basically, we've learned a strategy that works with these kinds of trinomials, and that is that when I go to factor it, and it's going to look like this, right? The factored form will look like this. And when I go to factor it, the two numbers that go here and here are going to add to this number and multiply to this number, right? These two numbers that go here and here. Okay, this is what we've learned. This is what you learned in the notes. The two numbers that go here and here are going to add to 12 and multiply to 11. Okay, they always add to this number that's being multiplied by x, and they multiply to this number on the end. So I'm looking for two numbers that add to 12 and multiply to 11. Now, if I'm thinking of two numbers that multiply to 11, there's only one option, right? 11 is prime, so only 1 and 11 multiply to 11. And notice how you're going to type it. You're going to type 1, comma, space, 11. Okay, the order doesn't matter. You could type 11, comma, space, 1. Okay, so those are the two numbers that add to 12 and multiply to 11. And then for the factored form, you'll write x plus 1, x plus 11, like this. Okay, and notice if I were to multiply these back together, right, and I can do this to check. I would say, okay, x times x is x squared. This is plus 11x plus 1x plus 11. And when I combine my like terms, I would get 12x here. Okay, so you can always multiply to check, right? But the trick is I'm looking for two numbers that add to this number, multiply to this number.